Good afternoon, folks. 2 o'clock here where I'm based in Los Angeles. I'm Ben Choi. I am the Google Cloud rep on the higher education team for my customers based in Southern California. For this call, I've also worked in collaboration with Berwick Group. Berwick Group is, for me, a very trusted premier Google partner. And then the main thing that we wanted to do is kind of sketch out an HPC scenario to which Berwick Group and the team have actually done work in production. So this isn't something in a brochure or a blog post, but this is really content culled from real life experience in serving a higher education customer called Caltech, based in Pasadena, Rose Bowl, here local to me. Today's presenters include really myself to help kick things off, but from the Berwick Group, Doug, a VP of Strategic Offerings, and then Dan Speck, VP of Technology R&D, and our good teammates, Jess and Nick from SCED-MD, which they will be having some of their say in how they supported the opportunity, their HPC environment that we're speaking of. If there are any questions for us, feel free to leverage the WebEx chat window. There is somebody who has taken a look at that. But without any further delay, we're excited to talk to you about what Berwick Group did with a very well-reputed research institute here in California. Doug.
Next, we're going to go straight to Dan. So Dan, feel free. My job seems to be letting people know that you're muted.
Hoping that wouldn't happen.
But all good.
So today we're going to be talking about Google Cloud and how it supports research computing. And so we're primarily going to be focused on high performance computing and the SCED-MD Slurm integration. But just to set the table and to let everyone know, Google Cloud supports a wide variety of different use cases and types of science. And that can be from high performance computing, machine learning, running science pipelines on the cloud. There's a general trend around seeing a lot more scientific computing being run in the cloud. Some examples are we're involved in a large project for astronomy, and that's a good fit because the cloud supports really large data sets and large scale data processing. Some of the work we talk about today was for climate science and doing climate modeling with high performance computing. And then there's a lot of use cases around medical research and biomedical data with using the Life Sciences API from Google and Terra.bio, and just be able to run their basically workflows on GCP. So I'll move to the next slide, please. So why high performance computing in GCP? There's a variety of reasons, starting off with cost. So one of the advantages of using the cloud is you can get the resources on demand when you need them and only pay for what you use. And the integration we talk about with Slurm today really achieves that in being able to spin up ephemeral resources, and you only charge for when the jobs run, and you can have visibility into who's submitting the job, so if you need to do any chargeback. Next example is the latest hardware. So being able to run the latest GPUs. Some examples are when the A100s came out, Google was the first cloud provider to have the A100s. And so being able to run those and being able to run them even before they're released to the general market. Also on the Intel and AMD side, being able to run the latest chipsets. And then also having those being set up in an optimized configuration. Google upkeeps images that have the latest drivers for NVIDIA and set up so that it's optimized for performance. Then moving to global, being able to run resources close to the data or wherever you need to run them within the world. It all looks the same within GCP, and you just pick the region where you want to run it within the world. And then going to storage, there's a lot of different storage options which we'll go through today. Both being able to store data in the cloud for job submission, also for long-term storage, and then how do you synchronize or integrate data with on-premise. And then optimize scheduling. Really with HPC and Google Cloud, you can think about, not just large jobs or jobs that need the newest hardware, but how can we have our end users submit jobs and not be waiting as long as they may be certain times a year to get their jobs to run. And then the last part here is just um, GCP has managed services included for the different services, so that can support the underlying hardware that, today we're talking about Slurm, that Slurm runs on. So, all right, so going into the integration, so Google is partnered with SchedgeMD. We have Jess and Nick from their team on today. And so it's been a multi-year partnership to really develop an integration. And so there's a GitHub repository that has all the integration code, and it's built into how Slurm can submit jobs into the cloud. So how that works is there's a couple different modes of integration. You can run a cloud-only cluster, and you can also integrate a existing Slurm cluster with GCP. And so you can either take that cluster and burst to the cloud, and that's where the controller and the login nodes and all that Slurm infrastructure is on premise, and just your compute nodes are in the cloud. You can also federate, where you put a controller node and login nodes in the cloud, and you federate those with your on-premise cluster. So two different deployment options to burst to the cloud there, and it really gives you flexibility in how you want to run resources. So an example here, this is a project that we had the privilege to work with Clemson University on. And so they were wanting to run a very large workload, and we'll get to the scale on the next slide, but this workload, they wanted to use preemptible VMs. So one of the advantages of GCP is they have a concept of preemptible VMs. And what those are compute instances that are 80% off the normal charge to run for a virtual machine. So they're very cost effective. They are available in any instance size. So they're not like a spot instance, for example, where you only have certain instance sizes available. They are available for any of the instance sizes. And the only catch is they can run for 24 hours, and they can be taken away if Google Cloud has low capacity at the time and they need to reclaim them. So they're a really good fit though for jobs that you can submit in a batch and that you're okay with restarting. And so the SchedgeMD Slurm integration supports this, where you can run those preemptible VMs. So for the job we're describing here, we did this all in preemptible VMs. We used custom machine types, and with custom machine types we can pick the CPU and memory that we run. So we can get very specific to the jobs and the resources that we need. And so this is also unique to Google Cloud and the ability to do that. And so this graphic here just shows with Slurm on GCP, we're able to get 5,000 nodes live in under 7 minutes. And that's with deploying a cluster, submitting a job to the cluster and have those nodes spin up and not being live and spin up to 5,000 in 7 minutes. Okay. And so then this is the view of the total workload that was run with Clemson University. And so in total it was 2.14 million cores run for around 5 hours, and is 130,000 virtual machines. So as you'll notice here, just the ability to scale quickly and at scale, starting off at 9:15 in the morning and having roughly 1 million cores an hour later, and then 2.5 hours into it getting to peak. So just the ability to scale and run this in a global fashion with a lot of resources. So This is at the large example. Now we'll talk about some of the examples where you can run smaller jobs. So now we'll go into architectures here. So with the on-prem burst to cloud, this is really the model of, okay, we have a software directory, we have existing identity systems that we want to extend, we have storage, and that storage is going to be the input data, and then where we want to save our output data. And our scheduler is also on-prem. So assuming we're at a major version 19 or 20, we can burst to cloud from our existing cluster and also integrate and use that same software that we already have installed, integrate with our storage, and use the same identity. And then what we need to do that, and we have another slide on the next slide, we'll go into this architecture, but we just need networking, and then depending on our storage needs, we can either integrate with storage on-prem or synchronize that. The other model is cloud native, where this is where we can spin up a whole Slurm cluster in GCP and have the users submit their jobs there. That GitHub repo we referenced earlier, it uses Terraform, and that'll create a cluster in GCP in a couple minutes, and then someone can log in with their Google credentials and do the normal SBatch, submit a job, and that will spin up nodes to run the job, and it comes default with a couple partitions. And so that configuration can be modified to match really the workload you're looking to do, but it's a great way to get started. It's a way if you're an individual researcher or research group and you don't have a cluster and you want to be able to submit jobs. So here's that overall architecture of burst to cloud we just referenced. This is from a customer example. We're also showing in components of the request process and then our billing portal. So how it starts is there's a request process, and that request process will say, okay, this is a research group that wants to use the cloud to submit jobs. And so there's data out of that request process in terms of what's the group, what types of machines do they need, like CPU memory, do they need GPUs? And so that data then gets put in a partition configuration into Slurm. So within Slurm, this burst to cloud, we're using a feature called power saving and resume, where we can specify certain partitions to burst to the cloud here. So in this design, we configure an individual partition for each research group, and so they knowingly submit to the cloud, basically if they want to run their job there. So this is on premise here in the pink, and they will submit the job. It'll go across the VPN to GCP, and so then the compute nodes are spun up in US West 1 here. So that networking, it can either be a VPN. We've recently modified this to use an Internet 2 connection for this customer. It can also be a direct connect. It's just IP level communication is needed because of how Slurm communicates between the compute nodes and the controller and the login nodes. So these jobs will run, and then when they're done, the nodes will spin down. And so from a software side, what we're doing is we're pointing the nodes at an NFS directory on premise that has the software, and so the software is loaded. We're also there's a Slurm integration to integrate identities from on-prem to the cloud, so they use the same Linux user and Linux groups to access the nodes, so all the permissions carry forward to the cloud. And then for storage here, couple different models. For them, we've integrated storage with on-premise, so we're just pulling data from on-prem. We're also testing out the on-premise transfer service, and that's a newer capability available from GCP where that'll align with job submission, where you can submit submit your job, and then have data flow into cloud storage based on the job. There's also different storage options available depending on what your current storage solution is, like a DDN or a GPFS. There's different software available in both those architectures to synchronize a parallel file system into the cloud. So storage is always usually the most nuanced and tricky part of this, so it just really depends on the scale at which you're starting with. And then did want to mention that that cloud storage can be mounted into the compute nodes, so you could access that directly. And then just want to note here, the final parts are, so all this is deployed via Terraform. We've modified this from that GitHub repo that we mentioned earlier. And so that will deploy the entire environment. And then as I get a new researcher, it'll deploy a new environment. And then all the monitoring and logging is integrated with GCP. And then to the very left here, we have a Burwood billing portal, and that's basically taking in billing data from all this from this environment, and then there's budgets set in here. So if you have credits, it's available to switch over from credits to paid consumption if that's what you want it to do, or if you want it to turn off after a certain amount, or if the credits run out. That's what the billing portal provides, as well as end user visibility into all of their data and reports around their usage. And so it's able to be provided to them without giving them access to the billing ID if that doesn't make sense for your organization to do that.
I want to pause there just to see if there's any questions at that point, because there's a whole lot of information there. So any questions about burst to cloud before we move on to cloud native HPC? You can hit the raise your hand button. You can type it into QA or chat. If not, we will continue on. Looks like no.
Okay, so this architecture here is for cloud native HPC. So this is everything's running in the cloud. So you could use the GitHub repo. Yep. And then question here from Elizabeth on, can you talk about how software licensing works? So if Jess, you want to take that one.
Yeah, I'm Jess Arrington. Thanks for your question. With Slurm, there is no software licensing cost there. It's open source. The services that SCEDMD provides is for support, and that's based on a per node per GPU basis.
Okay, thanks, Jess.
You bet.
So with cloud native HPC, this is, we mentioned earlier, there's a GitHub repo with that both Google and SCEDMD developed. And in that, there's a Terraform, basically templates that get deployed. And so this can deploy this environment for you. And in that, there is identity-aware proxy for your end user access into the environment. And then there's the Slurm login node, the controller, and then the compute nodes. And so this script will deploy the whole environment, and you'll have an image that you can use to run your compute nodes from. And so it's as simple as a couple minutes after this deploys, you could log in, you could take an existing script you have from on-premise, and assuming you can stage the data in GCP, and you can either put that on the controller. By default comes them with an NFS server, or you can put an NFS server in GCP, or you can have it in cloud storage. And so then you submit that job, and then the compute nodes will get spun up on demand. And then you can specify if your partition wants a GPU or not. So like I said, this is a good fit for just testing it out. If you're interested in running exclusively in the cloud, or if you're an individual research group and you just want more of a self-contained solution. So And then again, everything, all the constructs around our billing portal fit this as well as the other GCP components.
Great, thanks, Dan. So the next section, we're going to just talk a little bit about getting ready to do HPC on GCP. So there's an assumption here that you may or may not already be using Google Cloud Platform within your institution. If you are not, there's some obvious first steps to be taken just to get access to it. So from an identity perspective, from working with your security group to ensure that any policy related things that they have concerns about using cloud are answered and set up in a correct way. So Burwood has a GCP onboarding process. I'm going to finish this and I'll come to your question, Ashita. So we have an onboarding process that goes through and gets all the technical setup set. So we want to make sure that anyone that we're working with is successful leveraging GCP and doesn't have to continually run into hurdles because you're the first one within your institution doing something, or you're doing things that haven't been defined. So we have a process to make sure that we define the roles, responsibilities, how you get access to things, constrain permissions as needed, and get things up and running. So that's what that is. And the last bullet point, which is not to be overlooked here, is the request management process, so that when someone does want to start using GCP, the roles and responsibilities associated with asking for it, knowing who to ask. Is it in a request management system? Is it an email that you send? Is it calling up someone? Is it walking over to a cube to say, hey, could I get access to this? So that we understand what's coming in, that there's a budgetary conversation about that, because getting access to HPC assumes that there's funding associated with that, and you want to make sure you know how the billing is going to work as it relates to that, and having all those questions answered up front before you spin up a project. The billing portal that Dan mentioned a few times, just to reiterate on that, the real benefit is that when you're spinning up things in high performance compute, you can run up some relatively significant budget impacts on that. By having the monitoring in place and our portal looking after it, you can set a hard limit of, as soon as we see that it's crossed a boundary, we can disable billing against that. So it is a fail-safe mechanism, as well as an ability to put in alerting for your spend, so you have that situational awareness while the things are processing. So how do we use proprietary software such as MATLAB? Would institutional licensing work? I'm going to look to Dan or others for this. I believe it would be just a separate licensing for that, right?
Yeah, so MATLAB would be like a bring your own license, and then assuming just, you're licensed for the appropriate number of virtual machines you're running.
That's it. Thank you. So HPC on GCP, we're through the onboarding now. You have access to the environment. What we do next is make sure that we have everything that Dan went through in the architectures of spinning up. We're setting the automation scripts, defining how it's going to work, roles, responsibilities, permissions. That work is work we do to make sure that those templates are available for your continued use. So then you can get in and start creating projects. And then finally, it's working with the folks from SketchMD who have a pilot offering to say, as you work through your initial projects, they can provide that support to ensure that you're successful in what you're running through. Jess, I don't know if there's more that you can say about that last piece.
Yeah, thank you, Doug. Appreciate it. I'll be very brief. The value that we position for sites with GCP and Burwood is that we come in and we're able to provide that technical help and expertise. Sites that usually kind of go on the path of doing it by themselves, we commonly see it'll take them about 9 to 12 months on their own. With SketchMD right by your side, with this pilot POC in the works, we commonly find almost with every situation they're ready for production in less than 3 months. There's calls that we do, and being able to interact with the developers and engineers with Slurm just helps them to understand some of the oddities that at times come up, and be able to architect and approach it very, very well from that standpoint. So these pilots that we do with GCP and Burwood are very, very beneficial.
Awesome. Thank you much. So I talked a little bit about our onboarding, what we're looking to do. So it is covering the governance aspects of things, implementing the automation, putting in those cost controls, addressing security concerns and making sure you guys are ready to move forward with leveraging. So again, it's about enabling the entire use of the GCP environment. It includes this checklist of activities. So I'm not going to drain this, but the takeaway is that we want to leave you with a fully operating system that's instrumented. It's logging to your SIM. You understand how access works. The network is in place to leverage HPC in the cloud, and that you have the ability to do the charging for the individuals who are running the projects, and you have all the visibility into that you need. The last note here, and then we'll open it up for general Q&A. If you're not aware, there's a program through the NIH called STRIDES, the definition is in the first bullet there, which provides, I believe, the best discounting that you can get on GCP to leverage it. So if you are leveraging grants from the NIH, know that if you're using GCP with those grants, there are very aggressive discounts available to you, and that's just a contract that needs to be signed to give you access to that those contracts. It also provides some other things around training. So NIH is here to help with you. They have a whole bunch of other services around this that can help you be successful in the research that you're doing. So a full team there, and if there's interest there, we can put you in contact with the folks from NIH if you don't already have a contact. So that brings us to the end of our prepared slides. I wanted to open up to questions about either what we've seen, what we've done, or anything that is curious to you. Again, there we go. Lisa, what is involved in the legacy cleanup step in the checklist? Thank you for asking. So a lot of the customers that we work with have had Gmail access in Google Workspace for a while within education. And with that, there's a free $300 credit with every account. And therefore, when we go in and look at, well, what's running already in GCP, we've seen 15,000 projects that are active already. And so we'll provide some recommendations on doing the cleanup. So one is we have a dormant project script that can tell you, look, this hasn't been used in 6 months. You can go ahead and delete it. And for those others that remain, part of the organization folder and project setup within GCP, everything is defined for permissions associated. Our permissions and policies are set at the folder level. So depending on what policies you want to enforce for those projects that were legacy, you migrate them into the projects where you have those policies defined, and then those policies take effect. So we'll work with you to design the folder structures, design the policies around them, and then take an approach to which ones get deleted, which ones get moved into a controlled environment, versus which ones are allowed to be more of a sandbox and proceed as they were. Another question came in, what are the roles needed to assign when using OS login? I'm not sure if that's a Slurm related question or a general GCP question.
Yep, so there's OS login, there's an OS login user, and then there is, so they're using identity, typically you'd enable identity aware proxy, and there's an IAP. If you just search for IAP, there's an IAP role or an IAP role for a tunnel user. And then the last part is they would need a compute user to be able to operate the VM. That's for like an end user if you want them to log in. And then for the, if you're going to be installing it, you know, let's say you're working with IT and you're a researcher and you want to install your cluster, you know, project owner obviously would give you all the rights you need to set it up. If that's not appropriate, you can, if you get compute admin rights, that'll be enough to get you to install everything. And then if you need cloud storage if you're gonna, cloud storage roles if you're gonna store data there.
Thanks, Dan. Feel free to type questions in the chat or Q&A if there are others, and I believe you can raise your hand if you'd like to ask live. Okay, don't see anything else coming in. So Ben, is there any closing statements you'd like to make about next steps for anyone interested?
Yeah, for anyone interested, please feel free to touch base with me. I'll put my email in the chat window. It's simply benchoi, BNCHOI as in ink at google.com. And I'll make sure to connect you with the right folks if it's not myself or the other representative if you're not from the Southern California area. I would say there are certainly some offerings in terms of a POC perspective that we can bring to the table. So we want to help you get started, but really understand your requirements and when you want to get done. But I think hopefully we've informed you that it's not just enough to think about the architecture and how the infrastructure is set up, but it's all about the user experience, right? Researchers are busy. They have many tools that they're used to and processes that they've been accustomed to for a long time. But if we want to take advantage of the cloud itself and really, eliminate the queues and really enable them to have controls in terms of when they want to do research and how big or small, and make sure that's fiscally in line. And also there are controls over how much you spend, because we don't want unbridled spend or unexpected spend. These are the ingredients and why I partner with Burwood and why Burwood is so trusted by other research institutes and also R1s to deliver this solution as an enterprise solution that's a long-term solution. So thank you very much. benchoi@google.com. Feel free to touch base with me and I'll get you linked up with the right folks. So again, appreciate the time.
And we will post the video. So I assume, Claire, you can confirm, but we'll send it out to everyone who was on the invite list. We'll assume that's true.
Yes, we will.
Great. Thank you, Claire. All right. If no final questions, we'll give one more shot for that. But Ben, thank you very much, and everyone for joining.